Well, first about me, I'm Paul Böhm, and I'm a professionally trained ninja and packet juggler. And I have been in security for a while. I recently worked, 2 years ago actually, I worked on quantum cryptography protocols at University of Vienna. And I found it quite interesting how bad the status of protocol development is and how much fun you can have with developing cool frameworks for various protocols. So I'll be talking about TCP/IP hacking tools today and about all the stateless tools that we already have and the fun you can have with them, but also about framework design and specific about a design for a TCP/IP stack that I've been working on. And, well, to look at the current status, we have lots and lots of cool tools to fingerprint and connect to and send packets to and scan, port scan on a stateless level. So we have Nmap for, and we have tools that do full connect, that use the TCP/IP stack of the operating system. So we have Nmap for scanning using SYN packets and various other scanning modes. We have POF from Mikhail Zalewski for fingerprinting single packets in a stateless way. We have tools which work on fairly stateless protocols like ARP for spoofing IP addresses, for returning wrong MAC IP associations. And they all have in common, they are fairly advanced, they are connectionless, and they operate on a stimuli response level, which means send a packet and wait for answers. However, the limitations of those stateless network tools are quite obvious. We can only scratch the surface of TCP. So after the first SYN that is sent on a connection, if we want to do active fingerprinting, we are out of luck. We can only fairly unreliably determine the operating system that the operating systems that are communicating. Okay. So those tools can only scratch the surface of TCP, and. Well, for example, people are trying to work around this. So POF has support for SYN plus X fingerprinting, and also for ECK fingerprinting, but it's fairly broken because the options that get sent along with a packet, with a SYN ECK packet and with an ECK packet, depend very much on the various options that you send with the first SYN. So you have state there. You have state for passive fingerprinting. You actually also have state for active fingerprinting. And also various tools which would be cool, which would be like IDS evasion for any exploit, for any... Well, I just leave it at that. Well, we can't, for example, do a TCP trace route. Say we have an existing connection, say we have a web server, and we get an incoming connection to this web server. It would be fairly cool to just be able to do a trace route over the existing connection, where we could learn information about the net that is on the side of the client. Or we might want to just use an exploit and use IP-ID fragmentation techniques like the ones, like the advanced ones Dan Kaminsky presented today. We could want to use that with any kind of applications that we're already using, but right now we can't. We need special purpose tools as soon as any of the tools we want to use become stateful or any Um, well, so what I've been thinking about for a while, for at least since 2001, is that we need a framework to write this kind of stuff. There have been really cool tools written, some released, scanners and various other cool tools that implemented their own TCP/IP stack, but they've always been fairly special purpose. On the other hand, we have really awesome, cool frameworks, even frameworks and tools, even though it's not very much necessary for stateless tools, stateless hacking. So, for example, Skippy, I will demonstrate it later, is a TCP/IP packet construction, encoding, decoding, and sniffing and sending tool, and it abstracts the whole problem. I mean, in the past, we had to write thousands of lines of C code to construct a single packet or analyze it. And with Skippy, you can write a complete trace route in about 3 lines or something. So really mind-blowing. But so far, we can't use that for stateful hacking. Yes, another thing that's really interesting is I think that everything that you learn about framework design can be generally applied to framework design. And what we learn about writing TCP/IP stacks and writing protocols is becoming increasingly important for peer-to-peer protocols, because it's fairly standard and has become common practice that peer-to-peer applications do net smashing and traverse firewalls in various ways, among them using UDP and leaving the connection. And so many companies developing peer-to-peer technology re-implement TCP over UDP. And it might be really cool for them if they, say, use Python to just take the stack that I'm developing and plug it into their application, and they have a full working, fully customizable TCP stack. Also, I think it's necessary to make some advancements to stateful fuzzing, meaning Skippy really is cool for testing various network appliances for the security, but we might want to go deeper. We might want to test aspects which are right now inaccessible because they require knowledge of the state. How is it done? Well, we choose an IP address and or a port. We can use an individual port that we run our own TCP/IP stack on, or we can use an entire IP address or a space of IP addresses. Right now, there's no support for that. And if the IP address is used by the host OS, we just block it using the firewall or the port. And if the IP address is unused, we answer the ARP requests ourselves. This really means we implement the whole stack from the driver, from layer 0 up to layer 4. Well, and then we do promiscuous mode sniffing on the Ethernet, and we just look which packets are coming in, which ones are for us. So if we have a layered architecture, the Ethernet driver looks for packets with the right MAC address, and just like a real TCP/IP stack does it. But we are user space, and this makes us very flexible. And then we answer the packets that we receive, and we send our own TCP acknowledgements and so on, but later more about that. So, what protocols are handled, or what protocols can be handled? The framework design that I currently have, which is my fourth rewrite, is based on a paper from 1995. I don't know who wrote it, but you can look it up. It's linked from the talk page on the 22C3 website. It's called a framework for network protocol software. And they originally developed it for TCP/IP and later adapted it for ATM, so it should be fairly flexible. And the way I'm implementing it right now, you have a driver, which is the hardware. You could theoretically have multiple drivers, which passes it on to an Ethernet protocol, IP protocol, UDP, and because of some library decisions which I made. There's even implemented HTTP and Secure Shell and DNS, which isn't integrated yet. So we should be able to handle all the protocols in a few weeks to a few months, depending. Okay, so what is possible if we have a complete stack and for now assume the design is flexible enough that we can customize everything, that we can change everything, that we can build things that before haven't been thought about. So, for example, new tools, things we haven't toyed with before, traceroute over existing TCP connections. Also, we could re-implement many of the man-in-the-middle attack suites using this TCP IP stacks in much fewer lines and much cleaner code. Also, it would be interesting to write an intrusion detection system using a high-level protocol abstraction, but that's been done before, probably. Then we can write peer-to-peer stacks, TCP over UDP, stuff like that. Of course, what also comes to mind is writing honey nets and stuff like that. Certainly would work. Then we can add modules, various kind of states or protocols or semi-protocols to the processing chain that take care of things like automatically adding IP fragmentation attacks to the packets, and overlaps. Then we could write the stateful scanner, which can send out a lot of packets, even if no reply comes, without wasting any resources or any ports. We can just reuse ports. We can bend the limits of the protocol as any way we want. Then we can full OS detection, of course. We can just pretend. We can just set the default values of various packets. Just as the fingerprinting tool do, we can record them and we store them and then we use them whenever we need to. So we can do both passive and active fingerprinting fooling. Also, we could improve OS detection because, as I said, POF only does reliable SYN fingerprinting right now. And I think tools like Nmap probably could also have the limits with fingerprinting because they don't really know so much about the state. Good, so how do we get, send, and process the data? Libraries and programming paradigms that I use. One of them is asynchronous programming, and it works like this. If you set the socket to be asynchronous, it means whatever you do with the socket, it's not going to block. If you try to read from the socket and there is no data to read, it's not going to wait until data arrives, but it's just going to tell you in implementation-specific ways, there is no data here, so try again later. So if we want to wait until data arrives on one or more data sources, we use the select statement or a poll or a KIO. Or there are lots of different ways, operating system-dependent ways of finding out if data arrives on a non-blocking socket. So the way it works with select, which is quite representative, is that you tell it, oh, I have these connections in self.connections, and I want to know for reading, and I want a notification when some data has arrived. In this case, I store the read list, the sockets that are available for reading now, and some other lists after calling select. And then for every socket that has received data, I read the data and I print it out. Fairly simple. If we want to generalize this, however, it's really cool to add a little bit of object orientation voodoo and to create objects with nice callback abstractions. For example, in this case, this is from Twisted, which I will talk more about on the next slide. It just gets called. It doesn't care about all this select stuff and operating system specific stuff, but it just gets called when a connection is made or when there is data to read from a transport. And in this case, this is a simple echo protocol. So if you use this protocol, it just reads data and writes it back. Twisted is a framework for Python for asynchronous programming, and it's huge. It has its own secure shell server, it has its own web server. The protocols are abstracted in a way that both client and server can share common parts, and it integrates well with various graphical user interface toolkits. It can integrate external main loops, and it has a very nice basic protocol infrastructure, which is the main reason I built on it, because I'm dealing with protocols. That's what I'm doing. So on the left, you see a simple twisted application, a complete twisted application, which is a chat server. You just connect to it to port 1025, and if you send something, the server sends it to all the other clients, or to all the clients. There's some more abstraction, so MyChat is not building upon the base class protocol anymore, but it builds on basic.line receiver, which is a protocol which receives lines. So we have really clean and nice abstraction there. Okay, then there's Skippy, which is a command line tool developed by Philippe Biondi, which is the best tool I've ever seen for constructing packets, receiving packets, sending packets, examining packets. So I'm just going to give a very short demo. I hope everything works. I haven't prepared this too well, just to show how powerful Skippy actually is. Okay, so I'm just going to construct an IP packet, put some TCP I hate this. Some TCP payload in it. Anyone want to try? I can do it. So IP and TCP, whatever. So I'm constructing a packet here for the nth time, and I put TCP payload in there. So maybe I want to put some message in there, TCP payload. Of course, it's a string, not a variable. Unintended. So now we have our hello message, and we can store it in a variable. We can look at it. I mean, this is not the complete representation. So if I use .show, I see all the hidden field values. Right now we have a source and destination address of localhost. So now I can maybe change the IP destination to something different, like whatever. I just send it to some IP address that exists somewhere. I don't care. And then I send it. Yeah, that's it. If I open Iforil now, if you're not believing me, I just send it out. I can do even other things. If I'm more specific, I could send out just hello, which is no protocol at all, to the Ethernet layer. So it's really easy to send packets. I also can sniff packets, like sniff count equals 1. And I just I store this to some variable, and then I get the first one, and I just received some packet, any packet from the wire. So yeah, and I can also examine this packet. It's a random packet I just sniffed from the line. It's not, I don't have anything with it to do. It's an ARP packet with some padding. So, and I can do different stuff. I can make a UDP packet. I can put in this case, I can put, probably should work, yeah. So it doesn't care how to stack the things. It can construct packets, it can dissect packets. So if I have some weird packet, like the one I had before, like this one, I can also get like ARP. I mean, you saw before, this one, it has an outer enclosure of ether, and I can just get the up layer itself. I can stack them together. There's this slash operator to put payload into some other protocol. So it's really cool. It does everything, encoding, decoding I need. Also, it can do stuff for SYN packets. I don't have a SYN packet right now, so maybe I just get one from the wire. Something like, I need some filter. Well, let's get just 100 TCP packets, something like that. Filters, TCPs. Make some traffic. Maybe 100 is too much. I'll take 5. Okay. So I wanted a SYN packet. I got any kind of packets. I didn't get a SYN packet. Too bad. That's some kind of presentation. Yeah. Okay, can I have the, no, I have it online. I have the presentation online, but let's switch, it's kind of pointless. I cannot continue the demo like this, but I cannot continue the demo without this laptop, sadly, but I will continue the slides. I can tell you what is working right now. Wie hole ich DHCP?
DHCP-CD, like, but it's currently VLAN. I think.
Ist es drinnen?
It should be
okay.
running, working.
Okay.
Advice. Maybe I have to restart the X server. Actually, some kind of problem. So ja. Ja, müsste laufen eigentlich. Welche Uhr denn nochmal?
Ich habe es online, aber... Okay. I have it online. I hope the net works. No, I don't get out right now. You need to...
But
I had
have
problem with the DNS server before. You should maybe configure a different...
But Wikipedia works.
Okay, now let me see.
I don't know, some, maybe just, yeah, I don't know.
Nein, garantiert nicht. Lass mich noch mit dem versuchen. Ich mache sie nur fertig, mal schon.
Was?
Ich versuche sie mit dem fertig zu machen.
Viel Glück wünsche ich dir.
Lass bleiben. Okay, I will just finish it like this if you see it. It should become readable. Nein, geht schon. Sorry for this, it just happened 15 minutes or like while I was preparing. So anyway, Skippy is really cool. And well, so how do we implement? How is the design of a TCP IP stack? How do we, I mean, we want to do it object-oriented. I mean, this is not even the 90s anymore, so it makes sense. There are good uses for it. So how do we do it? If we try to do it using inheritance, meaning we create a packet object, a packet class, and then we create an Ethernet class, and then an IP class, and so on. And each is a specialization of the previous one. As we will shortly see, this has disadvantages. Another approach we could take is composition, which means, well, you create individual objects just as before. Maybe you have Ethernet, and you have IP, and you have TCP. But they are not in any way in an inheritance tree, but they just talk to each other. That's composition. And this is really pure and beautiful and everything, but in the real world it doesn't work so well. So the third approach, which is my for free right, it's a hybrid approach. So I'm going to go through the design considerations now. With inheritance, well, it works like this. You have driver, and it dispatches to various packet protocols. And each packet, to various packet protocol style objects. So in the case of the one in the middle, you have a packet protocol, which actually is or the other way around. It's easier to understand. You have a class TCP, which inherits from IP protocol, which inherits from packet protocol. And to this, you dispatch the packet, or you dispatch it to the other one. So all the decision-making to where to dispatch is made directly after the driver, somewhere around there. And then from TCP, you dispatch to TCP connections again. So it's a kind of quirky thing, because you have two separate IP protocols, instances just for TCP and UDP, and if you wanted to have some variations between TCP, you would have many more instances. So that's probably not the best solution. So if we try composition instead, this is very close to the design you will find in the paper from 1995, which I mentioned. In this case, you dispatch from the hardware to something that is called, or you introduce something which is called a mux, which is basically the name giver for the TCP/IP stack that I'm talking about. And a mux is taking input on one side and giving output to, depending on some criteria, to one of many channels on the other side. And so if on layer 1 we have a mux, but right now we only have one outgoing link, so that's the Ethernet protocol. Above that we have another mux for layer 2, the network layer, and from there we decide whether to pass it to the ARP object or to the IP object. And the IP again passes it on to the third layer and decides, is it ICMP, is it UDP, is it TCP? And when we are at TCP, and I'm just going to show this part here, we have a port mux, which is just a different kind of mux, which decides, well, is it port 8000 or is it port 22? And depending on this, passes it on to a connection object. And the connection object takes care of passing on all the information and passing around the information between web server and our TCP/IP stack, or secure shell server and our TCP/IP stack. And all those connections do have state. Those states are object too. I will go further into why that is later on. And well, that's ninja style. Okay, if we simplify the design, and actually I took out the mux out of muXTCP because I don't think it's needed. You have it like this. You have the Ethernet protocol talking to IP, IP talking to TCP, and the Ethernet protocol, and so on. Maybe if you start here thinking a little bit, you might come to the conclusion that IP actually also needs to talk to ARP, and because MAC and IP address are not completely unrelated by any means. And also here you see maybe on top of UDP you later want to have DNS, so you have this whole stack of protocols, and you might want to construct this protocol stack using a graphical user interface or whatever, but generally there is some dependency. Even if you would want to construct it using a graphical user interface, there will still be some interdependency between protocols, especially if you want to write hacking tools, because everything we are doing influences everything else. So the hybrid approach, I don't have because it's really chaotic, is just accepting that in the real world things are chaotic. And so all the protocols can talk to all the protocols. And we use the singleton pattern for that, which is basically just saying we have global variables through various means so that protocols can find each other and communicate with each other. And protocols communicate in any way they want, and they pass around objects saying what they want to do. It's not strictly necessary to do that, but sometimes I support both. Direct packet building and requests to build packets, and command objects. Packets that are incoming are processed by the protocol chain. There's not much chaos there, though you can add diversions, so you can say, oh, now I'm entering a mode where I want to do some attack, and then things are not passed on to TCP, but some rogue protocol which does other things. And this is another diversion packets that you want to send. You don't pass down the whole layer structure till you get to the driver, and then it is sent. But the packets are sent by the layer generating them. They are merely asking all the other protocols to contribute in providing information to construct the packet and then make it ready for sending, and recording various state changes that happen by sending this packet. Another packet that is really, really helpful for maintaining the flexibility we need when we write a stack like this is the strategy pattern, which basically decouples the algorithm that we apply to state changes and within states from the actual protocol. So it's saying that the state in TCP listen, and all the logic that is associated with listening on a TCP socket is its own object. And when we make a transition from this state to a different one, it changes something in the protocol. It says it sets it to a different object. But the state, all this logic, it doesn't store data. It's just logic, which means we can easily add a new state, for example, for TCP traceroute, which isn't like we have listen, SYN send, SYN received, fin wait one. We have all those TCP states implemented as objects, and we can add a new one like TCP traceroute, make a transition there, let it do its stuff, send packets with increasing time to live, and later on switch back to TCP established after fixing up all the information in the protocol and continue as nothing would have happened. Yeah. So what doesn't work yet, I don't have IP fragmentation implemented yet. I had some experiments with that in a previous version based on inheritance, but that's not in it right now. Then most advanced IP and TCP options don't work yet. I don't have window sizes, I don't have all that fancy stuff yet, but I want to implement it. Then I don't have any ICMP handling right now, I didn't care. Things like simultaneous open or simultaneous close are absolutely not supported right now. I have no means to test them, they are really rare. DNS is not in there, which I hope to have really soon, or I think DNS is really important because you don't want to send out DNS requests from your main IP when everything else you are doing is coming from your own TCP IP stack. And well, ARP kind of works. I'm still not decided yet. I've played a little bit with it. Basically, it's really simple, but I re-implement it so often, so I don't really know what's the current status when I made the slides. So, yeah, so here you see I have basic ARP and I have full ARP, whatever. Then what's definitely working is the channel architecture, the channel protocol architecture, the conduits, for routing through packets and dispatching packets based on protocols, based on port numbers, based on IP addresses, abstracting that, avoiding having a class for each of those decision-making, decoupling all this decision-making from the protocols that you want to link together. Then I have semi-complete UDP support because it's really easy, though I don't have ICMP handling or message passing, which is another of those things where the protocols are really intertwined that can't be easily separated. Then I have all the basic TCP state transition for both listeners and Active Connect running without any problems. And I have rough twisted protocol integration. So what that means is I have a complete web server running, written in Python, running in the same process, in the same thread on the TCP IP stack. I have a complete secure shell server running on my own TCP IP stack where I do all my ARP handling, where I do everything, where I do all the state transitions. You can connect there, you can log in, you can give your password, you can do connection forwarding, whatever. It's all written in Python and in the same server. It's not written by me. I specifically designed the stack so I can reuse Python code that's already there. Yep. I will make another attempt of actually demoing this. I mean, there's not much to see, but I hope you can see it. So. They call it test-driven development, so my main program is test. So let's see if this works. Oh, well. Okay, so what's my IP address? I didn't completely configure it because of the problems I had with my display, but I should be able to get it to work. Okay, so here we have it. It's running, and there's some weird debug messages, and here it registers a connection. It sees an IP packet. Here you have a state transition from listen to SYN received, and then a transition from SYN received to established. Connection is established here, some more debug info, and what I have here, I think, is the web server. Yep. So I have a web server running on there right now. If I'm lucky, I might get to my web browser without the screen going away. I have set up my web browser with an external proxy. So I should be able to go to this IP address. Which was it again? On port 8000. Oh, well. I need to set up the secure shell tunnel first. Yeah, the DNS seems to have problems here right now. I noticed some problems before, so I need to switch to a different DNS server. Yep, so here I have a directory listing. There are a few twisted integration quirks which don't work yet, so I can't open a file, but I can open directories right now. But that's really just a very minor problem. Should be able to fix it in half an hour or so. So but there runs a web server, and you can see the packets that are going back and forth. While this is happening, I can also, I should be able to, I didn't test it actually, to another board and get an RST. No, it doesn't work right now. It's still heavy development, but, well, the web stuff works, and I can replace it also with, easily with, this is ugly. This is just hacked up for the conference, but I can replace it with the Secure Shell server. I just need to make some nice API for and abstraction for actually doing that later on. So, well, there we are. So now let's try to log in. Ah, that's tough. Let's see. I need to check my key. Keygen minus F. Let's see if it's the right key. Minus L, minus L, minus F. Host RSA key. 0257 C2. You should do this too, so don't laugh. Okay, so yes, it's the one I want. So I'm logged in on my laptop, back and forth over the internet, and the Secure Shell server I'm connected to actually runs on Python, does have probably almost nothing in common with Open Secure Shell, and yeah, I can still watch the packets that go across the wire while doing this. And I'm sending them myself. Okay, so what will work soon? Some outlook. I'm actually planning on, making this a full-blown stack with ICMP, ICMP error propagation, more IP support, more TCP support, tracing of existing connections. It's just something I always wanted for any kind of application, and all the fragmentation stuff, and OS spoofing. I think this is the stuff I can get to work with in the next month or so. Future goals are, I want a C-shared library interface. I actually don't know how fast this thing is, because I know this is going to be one of the first questions I will hear. So I don't have absolutely no idea if it performs. It just works for what I tried. So I'm still not thinking about rewriting it in C, but I'm thinking about making an interface so C applications can use it and can activate some of the functionality that is implemented in Python. And, well, I would like a server mode that somehow listens on localhost, has some clearly defined interface for registering new protocols, maybe a graphical protocol builder, protocol stack builder, asynchronous DNS, which should be quite easy, like sending my own packets, but using the protocol construction and protocol parsing routines from Twisted, which also provides the Secure Shell server and the web server. And I really want TCP over UDP. I've already been contacted by someone who says his company would like to have a complete TCP stack, outsourced TCP stack for the peer-to-peer protocol. So that sounds cool. And yeah, lots of applications. So that's the end of my presentation. Are there any questions? I will put it online today. I will add a link to the wiki. Any more questions? Okay, thank you.